So now we are going to shoot the projectiles from our little spaceship. So what does this really consist of? What do we have to do to start shooting projectiles from our spaceship? I think step one is make sure I have the right tab. So here's what we're going to do. We're going to have these little projectiles. They're going to be these little blue balls that we shoot from the tip of our spaceship. So we need to basically think out a few things. Where should these spawn relative to our ship? If we spawn them from our spaceship center, which will be about right here where this black dot is, then our projectiles are going to be coming from the middle of our spaceship. Doesn't really make much sense because they really should be coming from the tip. If a projectile were to come from here, it would just launch outwards. It would just look a little weird. So we want to make sure that they're coming from this exact location. And we could take care of that really easily by adding on a value of around 20 to 30 to whatever the tip of our spaceship is right here. But eventually, remember, we're going to be turning our spaceship. So when we turn our spaceship, we might be facing in this direction. If we were to just add on a value of around 20 to 35, well, we'd be spawning our projectile over here outside of the spaceship. So we always need to make sure that we're spawning our projectile at the tip of our spaceship based on our current rotation. So we're going to be using more sine and more cosine values to make sure that our projectiles spawn in the correct spot. So let's just get some basic projectiles spawning, and then we'll start altering them so that they actually spawn from the tip of the spaceship. So let's go over to our code. How would I go about spawning projectiles over here? Well, I want to start by creating a projectiles array. So right beneath all of our consts, I'll create another const called projectiles. And this is going to house all the projectiles that we have currently within our game. And then we'll splice them out of this array as they go off the screen and so forth for garbage collection. But we don't have a projectiles object created just yet because we never defined any class that resembles a projectile. So what should the blueprint for a projectile be? Well, let's go ahead and create it now. We have our class of player. Right beneath it, let's create a class of projectile. Uppercase P because we're creating a fancy class. Now we need a constructor because that's what is called whenever a new projectile is created. And what properties does a projectile have? Let's see if you can come up with some on your own. Well, I know personally, everything that moves on our screen is going to have some sort of position associated with it. So I'll say I want a position property on each projectile equal to the position that we passed through our constructor. Now we might have multiple arguments coming through this constructor, so I'm going to use that same method we used when basically creating that player class object, where we wrapped our argument in an object like so, and this way we don't need to worry about the position of our arguments, and we don't need to worry about not understanding what these arguments might be, because now we have labels associated with each of them when we create the projectile object. So we have a position. What else might a projectile have? Well, also a velocity. Equal to a velocity, which will pass through. And we're looking to be in great shape. So I think this is all we need to get started. Maybe actually we'll include a static radius. So I'll say that this has a radius property equal to about 5. That's going to go as a small projectile to start launching from our spaceship. But I need to determine what does a projectile look like. Let's do that now. I want to add in a draw method, arbitrarily named, and then I want a projectile to be just a circle. Do you remember how to draw a circle based off the previous lessons? Well, we're going to use c.arc, and whenever you use something like arc, line 2, move to, it's pretty safe to always call c.beginPath so you don't get that issue with the snail trail or lines not connecting as you render your stuff out on the screen. So we're going to begin our path, and then we're going to create an arc. And the first argument of arc is position.x. So we can put in here this dot position x. The second argument will be the y position, which we can get with this dot position y. The third will be the radius, which we have a property for that declared up above. This dot radius will be equal to 5. What else do we have here? Well, let's think. Where should our arc begin? At an angle of 0 radians. And then we need, where should our arc end? Well, I want it to be the full 360 degrees. So math.pi times 2 will give us 360 degrees. And then counterclockwise or clockwise does not matter, so we put false right there. Finally, we can close our path to be extra safe. And then we can fill this in with some sort of color. So I want the fill color, or fill style, to be equal to the string of white, just a simple white projectile. And if I want to fill this in, I'll call c.fill. That's how we're going to draw out a simple circle on the screen to resemble our projectile. But a projectile is going to be moving around. It's not just going to be static. So it makes sense that we call an update method as well to make sure we're updating position.x and position.y based off of our velocity that we're passing through for every frame we call update. So let's add in that update method. We're going to call this method update, makes sense. And then inside of it, call this .draw. We render out the projectile. And then we want to update the position on the x-axis, add on to the current position by whatever this .velocity.x might be. We want to do the same thing for y. So we're going to change position.x to y, and then velocity.x to y as well. And that should be all we need to create a valid projectile. I know I went through that kind of fast, but you should be somewhat familiar with it based on how we created the player class up above. But let's start rendering this out on the screen. Right now, we have this projectiles array, and it's meant to store all the projectiles because we should have multiple projectiles on the screen, not just one. So yes, we could create this one singular projectile and then call update on that, but we need a way to manage multiple, and this projectiles array is basically how we're going to be managing those multiple projectiles. So how do we begin pushing projectiles into this projectiles array and rendering them out? Well, we need to think, what event should we be calling to push projectiles into our projectiles array? And the event that should be occurring is when we press down something like our space bar. When we press space, a projectile should be launched. So where are we listening for our space bar? We're not listening for it at the moment, but we can, right here within our key down event listener. So we need to find the exact event code for space, and I think I got it on the first go based off my memory. So the case for a space bar is going to be space with an uppercase S. And then what do we want to happen when we press down a space bar? We could reference keys.space and set pressed equal to true, but we really just need to push in a projectile into our projectiles array and then render that out on the screen. If that's the case, we don't need to do anything with our keys object, but rather we can call our projectiles array and then call push on top of that. And then what do we want to push into this array? We want to push in a new projectile based off of our projectile class in which we just created. And we know this takes a few arguments, position and velocity. So where should our projectile be spawned when we press space? Well, on the x-axis, we're going to spawn it right at wherever our player is in the center. So player.position.x. Then y will be equal to player.position.y. This just means we're pushing the projectile to start in the very center of our player. This is not where it should be, but we're going to fix this to put it where it should be. So that's just going to get it on the screen. And then do we want a velocity associated with this? I think so. So our velocity by default will have an x and a y. And I just want it to start moving over to the right a little bit. So x will be equal to 1, y will be equal to 0. And that should get it moving over to the right. But yes, this pushes things into our projectiles array, but we won't actually see them until we begin rendering them out on the screen. We can begin rendering out the projectiles by calling in a for loop. So we're using a for loop instead of something like projectiles dot for each, because we want to loop through the back of the array and be able to splice things out and break out of the array as needed when we do things like collision detection and splicing. So we always want to loop through the back of an array rather than from the front if the object is about to be removed at some point in time, whether now or in the future. If we're not looping from the back and we're looping from the front and we take an object out of the array while rendering it out on the screen, there is the potential for a flash to occur. It's super annoying, but if we loop through the back, no flash is going to occur because there's no basically jumping between elements as we render them. If we start rendering things from the back and we decide we want to remove an element, we can remove it, then we go on to the next one within the array. There's no jumping of elements around because everything at the end of the array, we already rendered all that out. There's not going to be any jumping associated with future rendered elements. So I know that might be a little confusing, but that's the general idea behind why we're doing this, rendering things out from the back rather than from the front. So we want to use a basic for loop because that allows us to do the rendering from the back. So to do a backwards for loop, we want to declare a let of I. This is our index. We want to set this equal to the index, the very last index of our projectiles array. So we'll grab that with projectiles.length. And if we want the index, we have to subtract 1. Now we're going to run this for as long as I is greater than or equal to 0. This means we're at the very last element, or the very first element, because remember, we're looping from the back, going towards the front, and the very first element at the front is going to be 0. And then, from the very beginning of the array, or the end of the array, I'm getting a little confused there myself, we want to subtract 1 from I. So for every iteration of this loop, we're going to be subtracting 1 from I. We're starting at the end. We're saying run this until we get to the beginning. And what do we want to do as we loop through every item within projectiles? We want to select one specific projectile and then render it out on the screen. So to select that one projectile, we can call a const, get our big projectiles array, and then we can call an index on top of this. I'm going to use I to reference the current object we're looping over, and it looks like I'm doing this a bit backwards, honestly. So const projectiles, singular projectile should be equal to projectiles I. This is going to select one and store it within a projectile const. So if we do this correctly, we can call this projectile const and then call its update method, which we created up above when we created our class of projectile. Here it is. So we should be rendering out a projectile on the screen with this, and we're going to see multiple of them because we have the ability to push multiple projectiles into our projectile array using this space case in which we put within key down. So let's save this and finally go back on over to our code and then start hitting space. And you can see no matter where I move, our projectiles just start going over to the right, but they are showing. So a few issues here is one, they just go to the right. This is stupid. And two, well, when they go off the screen, they're actually still being rendered all the way off to the right. When they go off the screen, they shouldn't even exist because we can't see them, and if we're rendering out all this stuff off the screen, well, it's just computational power that we're using, which is wasted. We don't want our game to get laggy because we just created too many projectiles and we never actually removed them. So what do we want to do first? Well, I would say let's get our projectiles spawning in the correct location relative to our player. So we're spawning them from the very center of our player. I mentioned we want to spawn them from the tip. So let's add on a value to their X location so that they're spawning from the tip of our player. So where would that tip even be? Let's find our player. It's going to be right here. And if we look at our triangle, we are moving to a position X plus 30. So this is the center plus 30. We should only have to add on a pixel value of 30 to get those projectiles spawning in the correct spot. So, where we are pushing in a new projectile, we have our current X position, player position that is, which is in the center. But if we add on a value of 30, it should be spawning from the tip of our player. Let's go back to our game over here, save and refresh, and you can see those are definitely spawning from the tip. But if I start rotating around, it's still spawning from where the tip would be on the right hand side, no matter our rotation. So we took care of the first issue of making sure that they're spawned from the tip, but now when we rotate, we also need to make sure that these are rotated with the tip. So how do we go about doing that? Well, it's going to be very similar to how we started adding in the correct movement for our player based off of their rotational values. So we're going to have this unit circle one more time around our player, and currently we're spawning our projectiles right here to the right of the player, right about here. We need to rotate this on its own unit circle from the player. So its own unit circle would be about this. We need to rotate this little projectile right here all the way up here to the tip of our player's point. And we can do that using the exact same method that we're using to determine our player's velocity mixed in with angles. We're going to get the right triangle associated with the center of our player and the very tip of where they're rotated. So this is the right triangle right here. We're going to get the angle associated with this point. We get the angle, whatever that might be, in radians, and then we're going to essentially alter the x and y position of our projectile from right here using sine and cosine. So remember, cosine is this side, the ratio of this side relative to the hypotenuse, and sine is the ratio of this side relative to the hypotenuse. We're going to use these two values and add on to our x and y coordinate. And if we add on to our x and y coordinate using sine and cosine values, it's automatically going to put it in the correct spot relative to where our player is rotated. That's the basic gist of it, is we're getting these ratio values and they're always going to work perfectly together so that our projectile is placed somewhere perfectly within a unit circle relative to where our player is rotated. So let's start to do that now. Rather than spawn our projectile position at just a center value plus 30, we're going to be adding on something else. We want to add on a math.cosine value that is relative to our player's rotation. So we want to put in here our player rotation, but we still want to keep this 30 value. Rotation. There we go. I can spell. I'm smart too. So we want to keep this 30 value because the 30 value is how large is our circle? What is the radius of the circle? And we want the radius to be 30 pixels from the center of our player because that's where our tip currently is. So that's why we're keeping 30. We want to put our x position in the right spot relative to our rotation, multiply that by 30, and we should be golden with that. But we need to do the same thing for our y position. But instead of using math cosine, we're going to use math sine, plug in our player rotation to give us the correct ratio value, and multiply that by 30 as well. So now, no matter where we spawn our projectiles, using this code, they should always spawn from the tip. They're always going to go to the right because our velocity is still a little wonky, but that's totally okay. We're on the right path right here. So let's save that, refresh, and now when I rotate, you can see those are definitely spawned from the tip no matter where I move my player. So looking great, but we want to make sure that these launch in whatever direction our player is rotated. And we can basically just do the same thing we've been doing to determine where these are launched from and how to move our player based off their rotation. We're going to use sine and cosine again, but basically plug those into our projectile's velocities. So we can do that by getting rid of our static value right here for x and y. And we pretty much just need to take this math cosine function and plug it into our velocities. Same for our y value. I want to copy that and plug it into our velocity. And now this is basically going to give us any value 0 to 1 for both x and y, but they're going to be set at the perfect ratio based off of where our player is rotated to launch these in the correct direction. Let's save and refresh. And now you can see no matter where I launch, they are going in different directions, different velocities based off that trigonometry code that we wrote. It's a little slow though in my opinion, so we can always speed this up by adding a multiplier here. Something like 3 might be good. And if you want to be extra explicit, you can rename this to a constant such as projectile speed. Then we just need to declare it, which we can do up above with all of our other constants. So projectile speed is equal to 3. I think that looks good. So we're saying get any value 0 to 1 for both x and y based off of those magic sine and cosine values, and then multiply it by a multiplier. In our case, that's 3. Should speed up our projectiles quite a bit. So I start launching, and I like how that looks a lot. So we're almost done with shooting projectiles. That was actually a really good, quick lesson right there. But we want to make sure that we're always removing these off the screen once they travel off the screen. If I were to right-click and then go into our console and start logging out our projectiles, I need to go back on over to Sublime Text to do that. Whenever I press down space and push in a new projectile, I'm also going to console log out, console.log, our projectiles array. And I always want to make sure I'm breaking out of these cases. I forgot to break. I'm just adding that in real quick. But the main thing you want to note here is I'm console logging out projectiles. Let's see how this works. If I refresh and start launching, no matter if our projectiles go off the screen, this just keeps getting larger and larger. When they go off the screen, we want it to go back to an empty array. Otherwise, these are just going to keep animating. Their values are definitely increasing over time, even though we don't see them. So we need to take that into account as they travel off the screen. So, like I said, we loop from the back of an array when we want to start removing objects from it dynamically and render them out on the screen. And this is a great use case in which we want to start removing objects. So when does a projectile go off the screen? We need an if statement that says if the current projectile, which we're getting up here with const projectile is equal to projectiles I, if the current projectile's position on the x-axis plus that projectile's radius, so the right side of our projectile, if that is less than 0, because 0 is the left side of our canvas. Let me draw it out real quick. We have our canvas right here, and our projectile is going to be this little blue dot. So we're getting the right side of our projectile, which is the center, position.x, and then adding on projectile radius. That gives us the right side of our projectile. If we are moving towards the left of our canvas and that right side travels off the canvas, then we want to splice it out. So we have that right side, but we want to say if it is less than the left side of our canvas, which is equal to a value of 0. So less than 0. Then we want to splice it out. So we'll take our projectiles array, projectiles, and then call its splice method. Basically just says take out an element at this one particular point. What point do we want to take it out at? Well, whatever index is currently, and then this requires a second argument. It says from this one index, how many elements do we want to take out? Just one, that current element which is off the screen. So now when we launch projectiles off the left side of the screen, we shouldn't see them in our array any longer. Let's save and refresh, move towards the left, start shooting, and it looks like I forgot to include that console log code, and that was down here within this space case. So I'm console logging out projectiles, save that, go back to our game, refresh. We have one in there, but it's not going to be removed because it went off the right side of the screen. But if I shoot towards the left, we're going to have 2. Now that one should be removed. We should have 2 within our array once more. And we do. So we just need to take into account every side now to start removing these projectiles to make sure that our game is as efficient as possible. So that is happening right here. We can say with a comment, this is garbage collection for projectiles. But we want to add on a couple more conditions, and we'll use OR operators to do so. Now let's take into account the left side of our projectile. When the left side goes off the right side of the screen, we want to remove it. How do we get the left side of our projectile? Well, with projectile.position.x minus its radius. If that is greater than the right side of our screen, which is canvas.width, then we want to remove it from our projectiles array. We're not done just yet though. We need 2 more OR operators for the tops and bottoms of our screen. So let's get the top of our projectile, which we can get by referencing its Y position. Now we have the Y position, but to get the top of our projectile, we need to subtract our projectile radius, because remember, the coordinate system on the y-axis is reversed within Canvas, and if we're referencing the top of our projectile, we want to remove it when the top of the projectile is past the bottom of the screen. So if the top is greater than our canvas height, that's when we're going to remove it. Now we just have one more, and that is going to be the bottom of our projectile, which we can get with projectile.position.y plus its radius. That'll give us the bottom. And then simply, when the bottom is less than 0, the top of our canvas, we want to remove it. And this should be all we need to get going with removing all of our projectiles as they go off the screen. So I saved that, I refreshed. We have 1 in our array, went off the right. Now when I shoot again, we should only have 1. Good, perfect. So let's test the top. 1, 1, 1, 1, 1, 1. And yeah, you can see no matter how much I shoot, yes, it does increase over time as all of these projectiles exist. But eventually, when they're all off the screen and I shoot again, the projectile rate basically goes back down to 0 or 1 as we launch a new one. So absolutely perfect. I love the way this is looking. If we want to finish this off, we can simply get rid of that console log for projectiles. But otherwise, this is going to allow us to go back to our to-do list and check off shoot projectiles.